10.3, Arcs and Chords. Okay, there's a lot of different theorems and stuff that go along with this. We're not going to state them directly. All we're going to do is talk about their applications. I'm going to tell you how to implement those. So let's talk about the first problem here. Well, the first problem is very straightforward. All it is basically recognition. Okay, in terms of the circle, this is a radius. Well, x right here is also a radius, so that means x is also 16. Okay, the next problem, a little different. We still have this right angle in here. Whenever you see the right angle, this right here is a chord. That right angle means it bisects that chord. So that means over here, this is also 10.3. Okay, just something to note. Now, in terms of x is our diameter. Okay, well, there are a couple ways to do this. One is you could do Pythagorean Theorem and figure out what this is right here and then double it. But there's a much easier way to do this. You just have to be attentive to the details. If I know that this right here is 5, and I know that this right here is 6.4, if I combine those, 6.4 plus 5, that gives me 11.4. That is all the way from here to here, which is a radius of the circle. Well, then that means this is 11.4, and this is 11.4. Now again, if I had done Pythagorean Theorem using 5 and the 10.3, it would have given me this. But you don't have to, because if you just recognize from here to here is the radius, and you combine those two, you get 11.4, 11.4, which means that x is, you add those two together, and you get 22.8. All right, let's keep going. Here's another one. Oh, there's the perpendicular thing, the right angle. Okay, so again, let's think about this. If there's a right angle here, then this right here has to be equal to this. So that means this right here is 12.2. Now, there is no shortcut to this one. We are going to have to do Pythagorean Theorem using the right triangle right here. Okay, so I'm going to set it up over here. So it's x squared plus 12.2 squared equals 14.7 squared. And equal sign didn't come out. There we go. Remember, that's our hypotenuse. That's our C. Okay, so I'm going to use my calculator here. 12.2 squared would be 148.84. So I've got x squared plus 148.84 equals, now I'm going to do 14.7 squared, and that's 216.09. Sorry, I'm writing into the next problem. I'm going to subtract 148.84 from both sides. So minus 148.84. So it gives me x squared equals, that's 67.25. So then I take the square root, and x is 8.2. 8.2. Okay, let's go to the next problem. Very, very similar. I'm going to have to do some erasing here. Create space. So I wrote over the other problem. Okay. So something somewhat similar. The difference is x this time is this right here. Now, I'm still going to have to do Pythagorean Theorem, so instead I'm going to call this one right here y. So then I'm going to do y squared plus 17.4 squared equals 19.4 squared. Again, this is our hypotenuse. Okay, so I do 17.4 squared on the calculator. I get 302.76. Do 19.4 squared, I get 376.36. I'm going to subtract Let's give me y squared 73.6. Take the square root, and we get, okay, I'm going to say 8.58. I'm going to go 2 decimal places here. Now, that is y. So this is 8.58. But I need to find x. Now, what I do know, we did this earlier, from here to here is the radius. Well, I know what the radius is. It's right here. It's 19.4. So what I need to do then, I'm going to come over here. I'm going to do 19.4, the radius, minus that 8.58. If I do that, that'll give me how much x is. So 19.4 minus 8.58, and I get 10.82. So x here is 10.82. That's how far it is from here to here. All right, so some things involved here that you gotta kind of work through. Make sure you set it up correctly. All right, let's do this next one. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actually diameters. Okay, so again, this is kind of a review. We've done this before already in the previous lesson. Remember, if that's 80, then that means this right here is also 80. So if I take this one and this one and this one together, all three of them make the whole circle, which is 360 degrees. So what I need to do is I need to take 48x plus 1 plus 46x minus 3 plus 80, and all that has to equal 360 degrees. So now I'm going to combine these two. It's going to give me 94x. 1 minus 3 is negative 2, plus 80 would be 78, equals 360. Subtract 78 from both sides. Again, 94x is 360 minus 78. It's 282. Divide by 94. So then x is 3. Okay. Now, what I need to do is, it says I want to find arc VT. Arc VT. Well, arc VT is right here, which is this expression. So I've got to take 3 and plug it in here. So I'm going to scroll this up a little bit, and I'm going to take 3 and plug it into that expression. So 46 times 3 minus 3. So 46 times 3, and minus 3 would be 135. So that is the measure of that arc. So it's not just about finding x, but we have to plug it in. Okay, let's do this last one. Okay, so this time we have 5x plus 10, 15x minus 10, all on this one side, which is half the circle, which is 180. So my equation is going to be 15x minus 10 plus 5x minus 10 equals 180. Combine these two, that's 20x minus 20 equals 180. Then add 20 to both sides. So 20x is 200. So that means x is going to be 10. Now, again, I'm going to have to plug that in. Where do I plug it in? Well, it says look for arc DE. DE is this one right here. So I need to plug this in to that expression. So 5 times 10 minus 10. So that's 50 minus 10, which is 40. So that is the measure of arc DE. So a little review there as well. So hopefully this made sense to you, and again, we'll work on it together in class.